This is the best upgrade I've ever done to my lathe. I've been using this manual lathe for a long time, doing turning, cutting threads, machining metal parts, and recently I did an upgrade that completely changed how I cut threads and machine parts. Something about this doesn't look right. The feed feels different, the motion is different, and the crazy part. It turned my manual lathe into something completely different. No gear changes, no guesswork, and yet it cuts threads perfectly every time. At first, I didn't even trust it, but once I tested it, there is no going back. Let me show you how it works. This is the second part of installing NanoELS on my lathe. NanoELS can turn your lathe into something very close to a full CNC machine. Everything you've just seen was done automatically, and the best part, the whole project cost around $250. I designed the setup to mount a stepper motor on the cross-slide Leadscrew. It consists of a bracket, 2 pulleys, and timing belt. First, I need to extend the Leadscrew. I turned the shaft with a slight interference feed and pressed it into the Leadscrew. Then I machined the shaft for the bearing seat. The fit came out perfect. I also need to add support bearings to the Leadscrew. For that, I machined 2 recesses in the standard part of the lathe. Now I assembled the Leadscrew with the bearings. And adjust the bearing preload. I install the Leadscrew back on the lathe and adjust the backlash in the nut. I managed to get the cross-slide backlash down to about 1.5 hundredths of a millimeter. Next, I bore the pulley seats. Then I install the pulley on the Leadscrew. The stepper motor bracket allows using different pulley combinations. either two 20-tooth pulleys or a 24-tooth and 12-tooth setup. It's time for some GLC content, guys. I ordered my stepper motor bracket from GLC CNC and it was shipped on Friday with the express delivery. And today is Tuesday and the package is already here. I'm honestly impressed with the shipping speed. 4 days, 2 of them were the weekend, and the package is already in my hand here in Germany. Let's go to the close-up, open it up and see what's inside. The part is perfect. As usual, all the dimensions are spot on. It fits exactly as it should, with no adjustment needed. The surface finish looks really nice, and the machining quality is very consistent. Even small details are done properly. This is just one part in my project, but it's a critical one. So it's important that everything is accurate. What I like is that you can order parts like this in different materials: aluminum, steel, stainless steel, even brass, depending on what you need. They also offer different surface finish, so you can get parts ready to use without any extra work. Ordering is pretty simple. You just upload your 3D file, choose the material and select the key options. If lead time matters, you can choose the production speed that works for you. Then you pick the shipping method and confirm the order. For parts like this, it makes a lot of sense to order them instead of machining everything from scratch. It saves time, especially when accuracy really matters. I appreciate GLC for sponsoring this project. If you want to order, check the link in the video description. I am test fitting the bracket on the lathe. Marking the hole positions. Now I am tapping in 3 threads. It is really important not to break the tab here. There is no room for other holes. If a tab snaps inside, it's basically a disaster. Installing the motor bracket. I'm using a GT2 belt, 96 mm long, 48 teeth. Final tightening with the cross slide at the end of its travel. It's a bit awkward. The lathe is small and there is not much space, but it works. A quick initial test. This part will protect the belt and the lead screw from chips. And this is how the wires will be routed to the stepper motor. Installing the wiring. I'll be using my super secret 5 kW stepper driver. First, power on. The motor is spinning in the wrong direction. I'll update the controller firmware to reverse the direction and fix the motor control logic. I'll also set the backlash compensation to 0.03 of a millimeter. Uploading the firmware to the controller. Setting up turning mode. I'm making 0.7 mm on radius in 2 paces, with a speed of 0.05 of a millimeter per revolution. Now setting up threading mode. For an M10 thread, 0.92 mm depth, 1.5 mm pitch, 10 paces. Starting the process. Everything runs automatically. The final pass removed a minimal amount of material for a better surface finish. There is also an automatic mode for parting. Now let's try CNC mode with G-code. I created a 3D model of a sample part. Generating this G-code, uploading it to the controller and starting the machining. It took about 5 minutes to make this part. The result is perfect, and every part comes out exactly the same. I just reclaimed the stock and ran the G-code again. Even tapers are machined automatically. And this is a multi-start tapered thread. I have no idea why I need this thing, but it looks cool, and it really shows what NanoELS can do. Honestly, every machinist should have something like this on their lathe. It speeds up the workflow dramatically. All the links are in the description. You know what to do.